Hey, so here's a recap on how to figure out the direction of vectors, how to figure out their components or resolve vectors into components. In this picture, you see 6 different vectors and their direction is indicated either to the vertical or to the horizontal. It could be below horizontal, above horizontal, right of the vertical, left of the vertical. For the purpose of the exercise, I'm going to stick to north, south, east, and west, the usual geographic direction. North going up, east going right, left for west, and down for south. Each of these vectors, if you look at the give two directions for each, for example, 15 degrees northeast would be the same as 75 degrees east of north. So as we go through it, it will hopefully start making more sense. So let's look at the purple one. If I measure my degree from this horizontal, so it's going to be above the horizontal. That could be one of the ways to express this, above the horizontal. Or if this is east and I'm going 30 degrees north of east, then this is 30 degrees north of east. 30 degrees north of east. I could also have gone, I go this way and I get to the same vector, east of north. I went off of north and I went east of north. So this would be, if you subtract 30 from 90, you are going to get 60 degrees. So another way to express this would be 60 degrees, and this would be east of north. So basically you were talking about complementary angles. If you look at the blue vector, you have 20 degrees, and these 20 degrees go from north, and we're going east of north. So this would be 20 degrees east of north, or I could have gone from east, north of it, so that would have been 70, and that would be north of east. I'm looking at the green one, which is technically, if I go this way, this is 10 degrees west of north, so 10 degrees west of north, and then flipping it would have been 80, and I would say north of west. Let's see if it works. This is west, and I go north of west, and I will go by 80 degrees, all working. The red vector, if I trace it from west going north, that will give me 15 degrees. If I go west of north, so this would be west of north, and this would be north of west. If it's 15 north of west, then it is 75 west of north. The dark purple would be 70 degrees. This direction is, we are off of west. So we were looking west and then we went south of west. Or we could have gone looking south and we went west of south. So that would be 20. So dark purple, it is 70 degrees and we went southwest, which is the same as 20 degrees, but west of south. And then the last one is bright pink. In this direction, we were looking south and went east of it, or we were looking east and went south of it. Somebody hiked 12 kilometers at 20 degrees east of north. That's the displacement. Comprises 2 motions in one. You went a certain distance just strictly north and a certain distance just strictly east. Another way to think about it, if I call this vector A, then I can say that this is A of X and this is A of Y. Vertical component and horizontal component. Now the thing to remember, south and west are left and down. Those are considered negative. So left and down would be considered negative. We're going to be using trigonometry, and one of the ways that I refer to trigonometry is if you know the anatomy of a human eye, then it should be pretty easy for you to relate. Here's the corner of the eye. Here's the lovely eyelashes. If you think of a human eye, there is a part of the eye through which you see. So you see through the pupil right here. That's where you see. And then the part where you close your eye, if you get your upper lid like this, that's your closing your eye. So this is seeing, and this is closing. See starts with S. C starts with S, close starts with C. If you then compare this to a triangle, say that your upper lid is your hypotenuse. So this is the hypotenuse. And say you know the hypotenuse, and you were trying to figure out what the side would be. The one that is across from the angle, from the corner of your eye, is going to be found as hypotenuse times sine, and the one that is close to the angle, like you close your eye, that will be found as h times cosine. So if I'm talking about this 12 kilometers and this right here is my angle, then the one across, that would be the x component. So I would use 12 times sine of the angle, which is, in our case, 20 degrees. And then the one that is close to it, which is the vertical side, I will use cosine to find it, and it will be 12 times cosine of 20 degrees. So that's how you find the component of a vector that you know. Now, the next one is 46 kilometers, and it's pointing 30 degrees north of east. So that's my vector right here. That's the actual vector. It's 30 degrees north of east, and the length of this arrow is 46. So then again, here is just like a human eye right here. We have this side which we see through, so this would be 46 sine, and this would be 46 times cosine, because it's closing your eye, of 30 degrees. Now, both of these vectors are pointing up and to the right. They have the north and east components in it, and that's why they're going to be all positive. The next one has 59 kilometers, and it's west of north. So if I were to draw it, to kind of sketch it, what is 59 kilometers west of north? Well, this is west, this is north, and I'm going west of north, so this is what it's going to look like. And then that's across. So for my x component, I'm going to say that this is 59 times sine of 10 degrees. And then this will be the vertical, which is closing your eye, and it's going to be 59 times cosine of 10 degrees. The important part is to remember that if it's pointing down or left, then it is negative. And that is why I'm going to put a minus in front of this component, because the x component is pointing to the left. Right there, that's my vector right here, the one that I was talking about. It's this guy, and it's pointing left. Therefore, the x component of it will be negative. 123 kilometers, and it's north of west. In this case, 15 north of west. So I will sketch it like that. That's my north of west. Now, in this case, sine will be for the vertical, and it is pointing up, so everything is good. So I'm going to say it is 123 times sine of 15 degrees, and it's positive because it's pointing up. However, the horizontal will be, first of all, it will be cosine because it's like that, and it's closing your eye. 123 times cosine of 15, and we also have to put a minus because it's pointing to the left. I have 67 kilometers, and it's southwest. Now, both south and west are negative. Now, what does it look like south of west? West is this way. South of west is this way. So I'm going to look across at my vertical, and that's where my sine is going to reside. So I'm going to say 67 times sine of 70 degrees, and it's going to be negative. Whereas for horizontal, I'm going to say the same, 67, but now I'm going to use cosine because that's close. Cosine of 70 degrees, and again it's going to be negative because it's pointing to the left. Left and down are negative, up and right are positive. And the very last one, east of south, so it was 75 east of south. So again, if I look at it this way, my x component will be through sine, and my y component will be through cosine. So 35 times sine of 75, it's pointing east, so that is positive, and 35 times cosine of 75. So cosine of 75, because it's closing your eye right there, because that's your 75 right here, that's the corner of your eye. And you are going to say negative because it's pointing down. So negative 35 cosine of 75. Down and left, south and west are negative, and up and right, which is north and east, are positive. So that's how you, what is called, resolve a vector into components. You use sine and cosine to figure out what the components are.